Hey everyone, so I just wanted to make a quick video kind of just going over the worksheet that we'll be working on for the next 2 days. These are just the notes that we would have taken in class. I just wanted to provide some guidance because obviously, it's still somewhat of a new topic for us. So reading these problems, just looking over everything, I kind of wrote a guide here. So the first question is saying if a new car loses 20% of its value in the first year, what is your value after 1 year? Obviously, you take the value and you take 20% off of the price. That should be fairly easy. The second one says after the first year, most vehicles start to lose 15% of its value each year following. So we're writing a function that models the value of the vehicle after t years, after the first year. So remember your equation for exponential growth or decay is y is equal to a, b, and x. And I'll give you a hint. It's saying lose, right? So your b value is going to be greater than 0, but still less than 1. And remember, your a value is not going to be the original price of the car. It's saying after the first year. So you're going to take the number you get from the number you calculated in the first step and apply that for your a value in the second step. And 3 is asking what is the value of v of 4. That's obviously f of x or v of x is the same thing as saying y. So that just means when your input is 4 or plug in 4 for your x value. Number 4 says how much money do you have left over to place in the high yield saving account? You take the initial 100,000 and you subtract the price of the Tesla. Number 5 says if the high yield savings account has an annual interest rate of 7%, write a function to show the amount of money the account has each year. So you take the value from number 4, and that is going to be your A value. Then you take your growth rate. Remember, it's going to be a number above 1 because we are gaining money. We're not losing money by putting it into a savings account. And yeah, you just write the equation for that. Number 6, saying compare the average rates of change. Keep in mind, this is something that I feel like all of my classes are struggling with right now. Rate of change is y2 minus y1 over x2 minus x1. And just to describe it one more time, we're going from 1 to 4, right? So that means x1 is 1 right here. So you plug in 1 into your equation. That's x1. And then your y value, your output, is going to be y1. Then you do the same thing here, but this value is 4. And then your y value is going to be your y value when x is 4 is going to be your y2. And it's then it's just asking what is the value of the vehicle after 10 years? That means you plug in 10 for x. Okay, so this bottom part right here is we're making equations for population increase, and it's saying one of them increases by 60 people each year, and one of them increases by 4%. One of them is definitely linear, the other one is exponential. You just have to figure that out and then write those equations. In what year are the populations equal? If you put both of those into Desmos, you should find where the graphs meet. And obviously, remember, we're counting time positively, so just check when x is greater than 0. Then it's saying suppose Boughton's initial population doubles to 2,000 and maintains a constant rate of 50 people a year. Take your initial value, then take your rate. So now your new initial value is 2,000. And yeah, from there, you create a function. And then this one says suppose the rate of increase doubles to 100 people each year. So you take 2,000 and you add it by, whatever your rate is here. That's a little hint for you. And from there, you're just going to calculate it. Yeah, so yeah, take the equation from C and change the rate. That's all D is asking you to do. And then these right here, very straightforward. What can we say about the graph? It's a computer that's losing its value after you purchase it. Then it's asking for the price of the computer. That should be straightforward. The value of f when x is 1. But the value of f is the same thing as saying y. So what's the value of y when x is 1? And then it's saying the meaning of f of 1. For that one, you can just put that they mean the exact same thing. F of 1 is the value of y when x is at 1. So then how does the value of the computer, or how the value of the computer is changing every year? So find the rate. And an equation that defines f. So remember, initial point times your rate. And your rate's going to be greater than 0, less than 1. Then once you have the equation, f is asking you to plug in 10 to see if it's going to be a number, to see if the y value is going to reach 0 or if it had already reached 0. And from here, these two are just writing equations from these graphs. So take your initial, see how much the rate of change is, and you'll find it from there. Same thing here. Initial, find your rate of change, and you'll find your equation from there. And if you have any questions, I have a question board up on Canvas. And yeah, thanks for watching.